add up all the values in priority scores. And I bet it will just smash for key priority scores. Bing, bing, bing. 912. Hello and welcome. In this video, you're going to watch me solve day 3 of Advent of Code 2022, heavily relying on GitHub Copilot. And to get to the punchline, it did amazing. So far, I've done day 1 and 2. Day 1 was good, day 2 was bad, and day 3 was amazing. To be fair, I've had a very clear idea from the moment I read the problem about how to solve it. I understood what was a part of it. I only got stuck counting from 0 instead of 1 at one stage. So when you have a clear idea of the algorithm and you write some comments and you start writing the code, like just Copilot would just complete it for me. Even like little things that I might like look up. I somehow forgot how to print the index of a particular character in a string. It just, when I wrote the comment, it filled out the lines of code. It really feels like knowledge of an algorithm is sufficient to solve a problem. Like the looking for the specific function that you would look for in Stack Overflow or some specific documentation in a library. Like you don't have to do that anymore. So yeah, let's check it out. See what you think. The code links are going to be below. I'm going to open up a GitHub repo with all of these. All right, so here we are on day 3. Hopefully, I'm getting better with the GitHub Copilot and I'll be able to use it to do some useful stuff. Now, I am terrible at reading, so I'll try to summarize all of this. In essence, the day 3 problem consists of the following. You have elves carrying rucksacks full of luggage, and apparently these get mixed up. So these rucksacks have 2 compartments. So you have to split basically every line into 2 equal portions and then identify the repeating character. The repeating character in this line right here, for example, is the little, well, let's see. The first rucksack has the little p, the lowercase p that repeats twice. P here and p there. Once you've identified the repeating character, then you got to assign it a score. And the score is going to be between 1 and 52. Due to the sort of order of the alphabet type thing. So letters A through Z are 1 through 26, and then the rest are 52. And then to win is you just got to add the kind of score for each line, and you're there. So in essence, 3 stages of the problem. 1 is split them in half. 2, identify the repeating character, and 3 is assign the repeating character. Given that I know the algorithm this well, and it's that straightforward, let's see if the Copilot can help me. So let's go. Step 1. We'll do it like in step. Read the input file and store the data in a list. Let's try that. Why don't we, with open, data f.read lines. Let's just print the data, because again, I haven't really used the read lines input. Yep, sure. Input day 3. Sure, this looks like, that's the data, including the new lines character. Okay. So data.readlines, store the data in the list and remove new line characters. Let's see if we can data equals to xstrip. So if I was to just rubbish that, restart it, the new line characters are gone. Nice. So step 2. Create a function. Ha ha ha. Okay, step 2. Split each item in the data list into two halves of equal length. Can you do this? Can you do this? For, come on. For item in data. Item equals item dot split. Not exactly. Not exactly. But let's create a new list, process data. I haven't lost hope. Processed data. And if that's a list, so for item in data, process data dot append, process data dot append, item, and this is kind of like there is a Python term like item like up to half, so you're gonna go up to half like that. Yeah, and let's see, up to half from half. Geez, this is gonna be good. So if it appends them like that, what if these were in a tuple, like you add an extra pair of brackets here? Print process data. Is this working? I think it's working. I think it's working. I think it's working. So if I look into the day 3 input, why don't I just bin that and then bing, 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 bing. Let's go to the top. So no, it doesn't really clear it. What are you doing to me? Clear? Oh, because I'm printing that data. I need to get rid of that. And let's go to the top. I don't know why, but yes, that's splitting it correctly. That's splitting it correctly. Brilliant. Brilliant. So now we've got these items in process data. We have some kind of, we essentially need to get to a total. Come on, where's my thing? Okay. We essentially need to go and assign, for each line, we need to assign the, maybe we can create a dictionary and we can assign like values. Finding the character that repeats between set 1 and set 2. And then a score for each line. Okay, so we can call this priority scores, and that could be a dictionary. So we need to identify the character that repeats in each line and then make that the sort of key of the dictionary, and then assign a value in the dictionary that is the alphabet. So like create alphabet from A. What if I did this to capital Z? Come on. Oh Lord. Print alphabet. See, that's so good. That is so good. Where are we? Where is this alphabet? Print alphabet. It prints it first. So I'm going to get rid of the process data. I'm going to clear it. And I'm going to run it. Doesn't do the capital Z. But these are the, so technically if you add 26 to 123 plus 26 is 149. No. Okay, maybe scratch that. What if it was minus 26? Minus 26 is like 71. Well, Z. Nope. That style doesn't work. The CHRs, you can you get all of these extra annoying characters. So from A, what if it was from A to Z and A to Z? What about that? What about alphabet equals A, B, C, D, E, F, G? Yes. Okay. 2 attempts. Wasn't the prettiest, but hey, we've got it. So we've got this alphabet. We've got this dictionary. So now we got to identify the sort of repeating character in the first half and the repeating character in the second half. I mean, really, like, we need to do this. First equals to that, and then second equals to that, and then we need to turn this into first comma second, because let's make this lead. Let's make this, you know, 𝗦𝗢𝗓𝗓 Copilot 𝗦𝗢𝗓. This is so, like, I'm loving it. This one's going so well. Okay, so now we got the first and second, and now I will say character C. What if I said find char C, which exists in both first and second? That's terrible. Not really an alphabet. We could say for C in first, if C in second. Wow. This could be it. Okay. So for each character in the first, if the character is found in the second, and there should only be one thing there, right? So if C in priority scores, you don't need to check priority scores. Okay, if C in second, priority scores C equals to the sort of index of C in the alphabet. That one. Yeah. And so what is it? What do I put here? I'm fully relying on it. Alphabet.index C. Cool. I wasn't sure if it was .index. I really think this could be it. So now when it's all done, I can print priority scores. Yes, look at that. That's amazing. So it identifies the letter that repeats, and then it gives you a score. The highest priority score in theory would be 52, and like 51 is there. Look, that looks amazing. And now I can just go add up all the values in priority scores, and I bet it will just smash it. For key priority scores, bing, bing, bing. 912. If this is correct, this is like the biggest win yet. Unbelievable. 912. Oh, my answer is too low. All right. Let's see if I misunderstood the problem. In the above example, this one, the repeating letter is the lowercase p. The lowercase p is going to have 20 something priority score, right? A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Yeah, 16. So 16. That's good. And then you add them all up. Okay. That is really good. So, am I missing something? The only item that appears in both, the only common item, they only share, but what if they have multiple priorities? Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of these item types? And my input was too low. My answer was too low. Okay, let's go back and take a quick look. Oh, but there could be multiple occurrences of the same thing. I have a feeling that that is the problem. So perhaps dictionary wasn't the data structure for me. Right. So if I did this, priority scores could still be the dictionary, right? But the key I'm going to make different, right? Line equals to 0. And then here, line plus equals 1. And then this could be string of line plus space, something like that, plus C. So now when I run this, there are 300 lines. And so if the repeating character was the same, each line is sort of identified more uniquely here. Let's try this again. So what's the total? Let's print the total at the end of it all. Because I understood this problem inside out. I'm like, why is this not working? 7718. Okay. 7718. $7718 is too low. My God. To say that I was confident doesn't cover it. I was very, very confident. Well, let's take another look. Annoyingly. So, oh my God. Really, 1 through 27 through 52. Oh, so that means that everything is higher by 1. That would mean that that's, oh my God, that's probably right. Wow. Counting from 1, guys, counting from 1. So, I don't know what to do here. So this is the index. So you just need to add. You just need to add key plus 1 here. That should give us a. 𝗦𝗢𝗖𝗓 or something. Oh no, you can't add 1, can you? 1 second. Key. No, that's the print statement, sorry. I need to do it where I create it. So priority is string plus C, alphabet index C. If I go +1 here, try that again, 8018. Okay, that's done. Let's do part 2. I'll put this aside. We have submitted 8018. Why don't we get the second part of the puzzle? Okay, return to day 3. Here we go. As you finish identifying the misplaced items, the elves have come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency within each group of the elves, the badge is the only item carried by all 3 elves. That is, if a group's badge is type B, then all the elves will have type B somewhere in the rucksack. At most, 2 of the elves will be carrying any other. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell is by finding the one item type that is common between all 3 elves in each group. So every group of, there's going to be groups of 3 that have a unique item. Every set of 3 elves in your list corresponds to a single, every set of 3 lines corresponds to a single group, but each group can have a different badge item type. So in the above example, the first group's rucksacks are the first 3 lines, and the second group like rucksacks. In the first group, the only item type that appears in all 3 rucksacks is the lowercase a. So this must be on their badges. It's the capital Z. Priorities for these items must still be found to organize the sticker attachment efforts. Here they're 18A for the first group. So you're adding more scores. And so 3 by 3, you find a common letter in the 3 groups, one letter that appears in all 3. And then find the item type that corresponds to the badges of the 3 elf group. What's the sum of the priorities? So do the priorities add up on top? I mean, I guess so. It's a new list of priorities that are group related. So it's 18 per group. So now we're going to have 100 groups. So instead of reading 1 line, we're going to need to read 3 and then find a common character in all 3. All right, let's put this in here. I'm going to create a brand new file for this. Copy, paste, and rename day 3 part 2. And if this here read lines, if we were organizing the data as like a tuple of 2 halves of a line, now we are going to append first, second, and third, and they're going to be doing like every 3 lines, right? So for item in data, I'm going to use this line thing here, and I'm going to say for item in data. So like if we're going line by line, Can I reference the previous item? Nah. Let's use the Copilot for this. Let's just do it. Group every 3 lines into a tuple and store in process data. My God. Oh, yes, yes, yes. Oh, yes. Print process data. This is going to work. This is really going to work. So now 1, 2, 3, 1, 2, 3. Oh, yes. Okay. So now that we've done the process data to work like that, we can even do the dictionary priority scores. Okay. If a char exists in all 3 lines, add it to priority scores. If C, for C data I, if C is in both of them, priority score is C. Yes. My God, this is unbelievable. 2518. Given that there are 3 times less lines, we're talking like 100. The priority scores should really be for key and priority scores. This is something needs to be fixed here, because if we're going every 100 and priority scores are a dictionary and they're empty, because they're going 0, 3, 6, 9. Fair enough. Fair enough. I'm just thinking string I here. If it was I divided by 3 plus 1. I divided by 3 and then plus 1. Can I just get 1 to 100? Yes. 1 to 100. 1.0. String of int I. Come on. Yes, 1 to 100. This was just neater. 2518. That would be the final answer. 2518. Where is my thing? Okay. 2518. Yes. Okay. That is it for this one. I was just about jumping out of my chair. Overall, I think the GitHub Copilot went really well. There's some basic things that I forgot, like how to print an index of a number in a list, and it just did that for me. But it also did some much more advanced stuff, like populating the dictionary that I created. All right, let's move on to the next challenge.